History of physics.
Max Planck.
Let's start with him.
All right. He was born in 1858 in Kiel, Germany. Okay. And I always love talking about the history of physics because, history in general is just super fascinating. But I want to put everybody here in the mindset of back in the day, in the 1800s. So forget pretty much everything you learn about, modern physics. Back in the day, it was just classical mechanics as well as like the theory of electrodynamics by Maxwell. And that's pretty much it. You know what I mean? There was, of course there was thermodynamics and all that stuff, but...
Oh, like a lot of Newton and all that good stuff.
Yeah. But at the time, people legitimately thought that there was nothing left to discover. They said, okay, we know like how bodies move, right? Just like classical mechanics, and how planets orbit. We know about the laws of thermodynamics, electrodynamics, all of that stuff. What else is there to discover?
Quite a lot.
Yeah, it turns out it's quite a lot.
Yeah.
But if you think about it, they didn't have, of course, the technology that we have today. And so it makes sense, right? You can kind of explain everything that you do on a daily basis somewhat. So, yeah, when you go into physics, you just learn what they have.
Mm-hmm.
And then they kind of tell you, well, this is all that there is to know.
Because I guess at that time already, so much had already been done that they were like, okay, at this point, we're just learning. Like even school nowadays, you're not really discovering anything. You're just learning stuff that's already been done. Yeah. So there's no real curiosity. There's no real inquisitiveness, unfortunately, that's lost, which is why they thought they're just done.
Well, right? I forget who said this, but somebody said at the time that the only thing left in physics was to get more and more accuracy in the experiments, which, due to quantum mechanics and all that stuff, we realized that there's actually a limit to how accurate you can get. But that was the mindset at the time, we just need better tools, better measurements, and we can just, move on from there. But, I also wanted to say that there were some like loose ends in the physics world, but most people thought it was just a matter of like not discovery, but just kind of tying those loose ends into the theories that they already had at the time. But cue in Max Planck, who was just working in his corner of physics, right? He was dealing with a little bit of thermodynamics, some radiation, right? And turns out that there was actually a very big problem in the radiation world. So first of all, I know we've talked about this before, but let's just talk about blackbodies. So a blackbody is something that absorbs all of the electromagnetic radiation that is pointed towards it and also emits, right? Yeah. And it's called a black body not because it's black, but because the color black, right, absorbs all the light as opposed to, white that reflects.
And it doesn't reflect.
All
exactly.
the light.
It doesn't reflect anything.
Exactly. So we have black bodies, and there's something called blackbody radiation, which in theory, before Max Planck, well, technically the statement I'm about to say still applies, but so a black body emits and absorbs all wavelengths of light, or not just light, but electromagnetic radiation. Sorry. And essentially what they had at the time was that this radiation, of course, can be plotted as a spectrum. The issue was that at very short wavelengths, so high frequency, high energy radiation, the graph just blows up. And so essentially what you would think, of course this wasn't true, but by looking at the electromagnetic spectrum, the emission spectrum, you would think that a black body would just instantly release all of its energy and its temperature would go to absolute zero instantly because of this like infinite energy emission. Of course, this is not true. So this was called the ultraviolet catastrophe.
Ooh.
Because, you know, there's just this huge hole where it's like, of course this is not what happens. There's not infinite energy. This is just not possible. And so Max Planck was dealing in this area of physics. And first of all, let me just say that the what am I trying to say here? The emission spectrum was actually derived from the second law of thermodynamics. And Max Planck tried to do the same thing and still come up with a reasonable solution that actually fit the data. Because we had the data. They were able to collect the emission spectrums of black bodies, and they saw that it did not coincide with what they had theoretically. So they knew what the curve looked like. And it kind of looked like a bell curve that was skewed a little bit over to the left side.
Like a skewed normal distribution, yeah.
Yeah. But, oh, sorry.
Video just went off.
Yeah, the video just got off.
Oh, it switched cameras.
1 sec.
Sorry. All the viewers are like, what is happening?
Okay. So Max Planck actually decided to postulate, or just assume, in his derivation of this spectrum, he assumed that electromagnetic radiation could only be absorbed and emitted in quantized energy packets. What a ridiculous assumption.
How do you even think of that?
Just
random.
It's so out of the box. Nowadays, with everything that we have, we look back and we're like, okay, makes sense.